let's review graphing linear equations using the slope-intercept form, y equals mx plus b. First of all, m represents the slope. And you know the slope is equal to the rise over the run. It's the rise in the line over the run in the line. B is the y-intercept, and that's going to be where it crosses the y-axis. So let's take our first example, number 1. Y equals 2/3 x plus 2. Okay, what you have to do is you look to see what your m and your b is. So if you follow your slope-intercept form, m, the slope, would be 2/3. That means the rise is 2 while the run is 3. The y-intercept, where it crosses the y-axis, is at 2, positive 2. So to graph this, we always start at b. B is first, m is second. So we start at 2 on the y-axis, so we put us a point at 2. Okay, then what we'll do is we'll just count our rise and our run. From the point, do not start at the origin, start with the point, the y-intercept. You rise 2 and you run 3. The rise is 2 up. The run is 3 across. Now once you get those 2 points, all you've got to do there is connect that line. So hopefully this works. Now that lines are infinite, we do put arrows on the end to show that it's infinite. And that's how you graph using the y equals mx plus b, the slope-intercept form. Let's do another one, make sure we've got that under control. Let's move this guy down. Another example, let's look at y equals 5x minus 3. Okay, following the slope-intercept form, the slope is 5, and the y-intercept is a negative 3. You always pay attention to the sign that's in front of that number. Now, going back to the slope, remember the slope has to be rise over run. And what I'm looking at is just the 5. That's the rise. So the run, we have to put a number under there to make the run, but it has to be equivalent to 5 when we're finished. So the only fraction that's equivalent to 5 is 5 over 1. So we put 1 underneath the number when we need a run. Okay, we're going to start with negative 3 at the y-axis. And then we rise up 5 and we run across 1. So I rise up 1, 2, 3, 4, 5. And then I run across 1. Once I've got that done, I put that dot. Now notice I didn't put a dot. When we rose up 5, a dot does not go there. You don't put a point there. You just put a point at the end of the rise and the run. Okay, and then you draw that line. And to show that it's infinite, you put arrows on each end. Okay? Let's do one more to make sure we've got it all understood. Last one. If I have y equals negative 1/4 x plus 6, my slope is a negative 1/4. My y-intercept is a positive 6. Now, people get confused here when you're trying to figure out the rise and the run. You know the rise is 1 and the run is 4. However, there's a negative sign with your slope. So where does the negative go? Does it go with both of the numbers? Does it go with the top number? Does it go with the bottom number? Okay, if your fraction, negative 1/4, if it's negative, you can put the negative sign with either the numerator, 1, or the denominator, 4, and it'll be equivalent to negative 1/4. It is wrong, however, to put it with the top and the bottom, because a negative 1 over a negative 4 turns into a positive 1/4. So when you're doing your slope, it doesn't matter if you put it with the top, the rise, or the bottom, the run. I like to go ahead and put it with the top. That's just my favorite way to do it. So I make it a negative 1 over a positive 4. You could just as easily put it with the bottom. Okay, to graph it, we start with 6, our y-intercept, right up here. Then we're going to rise a negative 1. Since it's negative, rise goes down if it's negative. So we'll rise down 1 this time. And then we'll run 4, and it still goes to the right. 1, 2, 3, 4. And that's where our second point comes in. Then I graph that line. Draw that line, connect those 2 points. And you put arrows on each end. And that is graphing using the slope-intercept form.